Welcome, I'm Laurel Moulton. I'm an extension educator with the WSU Regional Small Farms Program. The WSU Regional Small Farms Program offers a variety of resources and educational programming based on the needs of our local farmers in Clallam, Jefferson, and Kitsap counties. And of course, we welcome folks from further afield to join in our activities as well. Feel free to reach out if you have problems on your farm, or if you have suggestions for other educational topics, or if you have topics that you'd like to share and teach about on your farm. You can learn more about our upcoming activities on the WSU Regional Small Farms website. At that website, you can also sign up for our newsletter. You can find our online learning library where a recording of this presentation will be stored along with many others. And you can also request personal technical assistance with anything you may have on your farm. In this presentation, if you have questions, please put those in the chat box and I'll be monitoring those. We will interrupt Lindsey if there's clarification questions, but otherwise I'll hold them until the end. So with that, I'll introduce Lindsey and she can put her presentation up. I hope you'll join me in welcoming Lindsey DuToit. She's a distinguished professor and extension pathologist at WSU and the chair of the WSU Department of Pathology. She has served as the president of the American Phytopathological Society and was named a fellow there in 2022, among many other honors over the years. Her research focuses on the origins, spread, patterns, and management of diseases affecting important vegetable and vegetable seed crops at home and around the globe. As an extension pathologist, it has been her job to work directly with farmers throughout her career to help solve disease problems. She works with crops including cabbage, carrot, spinach, red beet, Swiss chard, radishes, and of course, onions. So we've invited her today to talk about allium diseases that are becoming more common, that many of you might be experiencing, and I hope you guys will learn a lot from Lindsey.
Thanks, Laurel, and thank you for the invitation to share some information on certain onion problems that seem to be problematic, particularly in Western Washington. As Laurel said, I work on a diversity of vegetable crops, both in Western Washington and Central Washington. So a lot of my work with onions has actually been in the Columbia Basin because it's a primary commercial onion production region for the state and for the USA. So some of my photos may look like they're very large fields in the Columbia Basin, and but I've tried to focus on principles that are relevant here as well. And Laurel had asked me to speak in particular about white rot, downy mildew, and then also about late season field practices that can help to minimize the problems with bulb rots and storage. So that's really where I'm focusing my efforts today, and I hope that addresses some of your needs. Let's see if I move forward. Next slide. Okay, so I wanted to just point out a couple of resources for those of you who do a fair amount of onion production routinely and might want to know about some useful resources. One of these is called the Compendium of Onion and Garlic Diseases and Pests. There's a second edition out now, and it's can be purchased from APS Press. It's an excellent resource, got color photos, got some management information and so on. It is due for a third edition. Just haven't had the bandwidth. I've been asked if I would help edit for the third edition. It's just because this one was published in 2008. And this book lists a wide range of diseases caused by, root and bulb diseases, foliar diseases, bulb rots, things that are caused by fungi, by bacteria, nematodes, viruses, and so on. But I listed these just to give you an idea. There's a wide range of things that can go wrong with onions, let alone the abiotic problems that are caused by non-infectious issues. And a second really valuable resource for those of you who do work with alliums a lot is published by the author is James Brewster. Again, the second edition is even better than the first edition. It's Onions and Other Vegetable Alliums. It's produced by Cabby. and fantastic, phenomenally good, dense amount of material on all aspects of onion and other vegetable alliums like garlic and so on. So these are two really useful resources that I turn to quite regularly. And I also thought it might help to take a look at some of the time frame when we usually see certain diseases become problematic. And this is really tied a lot to the environmental conditions that favor different pathogens. So obviously, if we direct seeding onions in the spring, that's when we might see issues with damping off or seedling blights. I don't see a huge amount of damping off problems on onions. Either people might grow them as transplants and then they're more tolerant when they plant it out. And also certainly in central Washington, a lot of the growers are putting seed treatments on the seed. So it's usually not a very major issue. The ones in brown boxes are more of the soil-borne pathogens that can be a problem anywhere from soon after planting, like onion smut or white rot, sorry. Onion smut is not found that often in central Washington in particular because it tends to like cooler conditions. White rot as well tends to do better in slightly cooler climates. And in fact, it's a quarantine disease in central Washington, but it is a problem here in our mild climate because it's favored by cooler conditions. There are some nematodes that can be problematic. Fusarium is a disease that attacks the basal plate, and pink root can be a problem, particularly in warm, dry climates. The ones in green are the foliar pathogens that can be problematic, like downy mildew, which is one of the diseases we'll talk about today. I see quite a bit of stymphalium leaf blight coming in secondarily on other things like downy. And then we have a few others I've listed there that aren't typically an issue in Western Washington. And lastly, in the yellow boxes are the bulb rot problems that can be an issue if you're trying to store your onions or can even start to show up at harvest, botrytis, aspergillus, and bacterial bulb rots in particular. So I think just showing you the time frame when these tend to show up in onion crops might be useful. And I see there's a question in the chat. Is that right, Laurel? Okay.
Nope. It was
sorry.
posted.
Okay. I also want to mention if you have a problem in your onions and you're not sure what it is, I have a list of Pacific Northwest diagnostic clinics. Besides the support you get from folks like Laurel, Jenny Glass in Puyallup is a really good resource for questions if you're not sure what the problem is. And of course, I'm just going to put my laser pointer on so I can. You always want to make sure you know what it is before you start trying to implement management practices. In my presentation this evening, I will mention a few pesticides, and I just want to put this disclaimer up so that it is your responsibility if you use any form of pesticide, organic or conventional, that you follow the label and not hold me or WSU liable. Okay, so let's move on to the problems that Laurel asked me to speak about. White rot. So white rot is caused by a fungus. It's got a mouthful. It's called Sclerotium sepivorum. And this is a picture I took back in the late 90s when I had Jenny Glass's job down at Puyallup of a white rot sample that came in. And you can see these little black specks attached to the bulb, which are the sclerotia, or the resting structures that this fungus forms on onions and other alliums. It's a worldwide problem, and in some areas it's enough of a concern that it's established as a quarantine pest. For example, Central Washington, which is a major onion, there's 24,000 acres of onion production in Central Washington, and some of those bulbs get exported to, say, Asia, Australia, and they don't want white rot being shipped on those bulbs. So it's a quarantine area over there, quarantine disease over there. Onion and garlic are very susceptible to white rot, and garlic can be particularly problematic. These little black structures called sclerotia that are about pinhead size survive for a very, very long time. They can be present in soil for more than 20 years and still be viable. And this is one of the problems with this disease. Once you introduce it, it's very, very hard to get rid of. And these sclerotia can sit dormant in the soil for a long, long time. They won't do anything, whether it's rainy, sunny. They will only germinate in response to allium crops being planted and the roots exudates into the soil, and that sulfur type compounds are what trigger those sclerotia to germinate. So this is, it's the real bane of this disease is its longevity in soil. The one good thing about it for onion growers is it's not seed-borne, but for garlic, because seed, it's not true seed, it's cloves, it can be an issue if you move garlic cloves around. So it can be more problematic in garlic because of this issue, but in onions, it's not seed-borne. So anything that moves soil tends to have that risk of moving white rot, particularly if you're buying transplants or garlic seed, as we call it. I'm just going to close my door so we don't have noise coming in that hallway. Sorry, I hear some people in the hallway. And so this fungus does well at conditions of about 50 to 68 Fahrenheit. So you can see cool to moderate temperatures in soil is where those sclerotia will germinate. If you get, they can actually grow at 40 to 74, but if it gets below about 40, 45 or above about 80 Fahrenheit, those sclerotia will not germinate. They just don't do well in those, not that 80 is extreme, but this is why this disease is more problematic in mild climates like Western Washington. This is a picture taken in Central Oregon, just showing you the degree to which this white rot can be problematic. So white rot has become such a problem in Central Oregon, which is a major garlic seed production region, that it's largely eliminated a fair amount of the seed production in that area. And it sits around for a long time. So you can just see the type of damage that occurs. And this is a close-up showing the above ground symptoms. You'll see it's just the plant, the tops just start to die back because those roots get impacted. It can't take up enough water and nutrients, and you start to see dieback of the foliage. When you dig up these plants, the classic symptom you'll see is the soil will be sticking to the bulb. And the reason is underneath that soil, if you dig around and carefully pull that soil back, you'll see the sclerotia and the white mycelium under there. You can just start to see it poking out here. So it can be misdiagnosed initially because you just see soil clinging to the bulbs, and it's because of all that mycelium. And this is a picture of some soil that was sieved to find the sclerotia, and you can see the size of these sclerotia. It's about a pinhead size. They're pretty small, very circular, and this is just all of these particles in the soil. And then those sclerotia will germinate, as I said, in response to exudates that allium plants give off in the soil. I wanted to show you another example of a problem. This was an onion seed crop I was asked to go look at in 2014, and all these areas that you can see from this aerial photo where the growth is very poor were infected with white rot, and this is in the middle of the quarantine area. So this field has now been placed under quarantine for 30 years. And any equipment that's moved on and off has to be, basically pressure washed and steamed so that you're not moving soil. And this was an interesting situation where it was an onion seed crop, and onions are grown from true seeds, so it's not seed-borne. The question is, where did it come from? The seed crop, the previous seed crop was in 2008-09. It's a biennial crop, so it takes 2 years to grow seed. It was direct seeded, so which means it was planted from seed, not from bulbs. But apparently some of the male line, this was a hybrid, so there were male and female lines, some of the male bulb plants were winter killed. And so they brought in some bulbs from the Treasure Valley of Oregon to fill in, but they assured the grower that those bulbs had come from a white rot-free area. So the only other possible source of introduction of this is as sort of brainstorm back into how on earth this pathogen got introduced to the field was that this field had been planted to a sugar beet seed crop in 2006. And sugar beet seed production is biennial as well. It has to go through the winter to make it flower. Those plants won't survive the winter in Central Washington. So the roots were grown in Western Oregon and in Arizona. So they shipped in roots that had been produced and vernalized, but came from a white rot area in Western Oregon and in Arizona where there was no white rot. So there's a likelihood that when they brought those sugar beet roots, and not that the sugar beets were infected, but there's lots of soil adhering to those roots. The sugar beet roots were grown in a field where white rot existed. They could have inadvertently introduced some white rot inoculum. So I point this out just to show you that even though sugar beets is not a host to this pathogen, just the fact that all that soil got moved demonstrates a risk when you move soil of moving some of these soil-borne pathogens. And something like the white rot pathogen is very problematic because it's so persistent. So this created a big issue, as you can imagine, a headache for everyone involved. And so this is a close-up of that field. I went out to the field with the grower and the seed company, and you can see the plants are dying back. Here you can see the soil adhering to the bulbs, and here where I've started to cut open, you can see the sclerotia and the mycelium. Again, that mycelium makes the soil adhere to the bulbs. So how do we manage this disease? And how do we avoid it? More importantly, that's your key thing, is avoid it. Unfortunately, when growers tend, particularly around a lot of smaller scale farms or co-ops with lots of farms sharing equipment, this is one of those diseases you really have to worry about. Another one that we see problems with is clubroot on brassicas, because when equipment is shared around, it's a soil-borne pathogen that's very easy to spread. So it's a really good example of why it's always important, if you're borrowing equipment from someone, make sure it's been cleaned off really well. If you're loaning your equipment to someone, make sure all the soil is removed before that equipment gets moved or comes back to your farm, so that you're not moving these pathogens with the soil. So that is really the key with white rot, is to try and keep it out as best you can. And avoiding infested fields. When your field is infested, if you grow an allium on that crop, it's going to be a problem. If you have a very low incidence, you may be able to get those plants out and dig some of that soil out, and basically not, monitor really carefully to see if you did actually get rid of it. The fungus doesn't like cooler, warmer temperatures. So in areas like hotter regions, not Western Washington doesn't get hot enough, delaying planting until conditions are warmer can help reduce losses. There are some fungicides that get used on a commercial level. Soil fumigation just does obviously not work, and not cost effective. But I'll talk a little bit about these things called germination stimulants, because it's really fascinating and offers some opportunity for folks, even on a smaller scale, if you do end up with white rot in your field. In some areas, they've looked at things like flooding, but you have to have fairly extensive periods of flooding in order to have some effect. In very hot climates, things like soil solarization can work. It doesn't work in our area. We just do not get warm enough. And unfortunately, there isn't any resistance in allium species to this pathogen. This is a photo taken of a trial in Central Oregon where they were looking at different fungicide treatments. And you can see how some clearly have no effect, and some had some really good effect. This was not just to show you that people have been working on this disease for a long time, trying to find ways to manage it when fields are infected. I don't expect you to know any of these names. I just want to use this as an illustration. This was a trial in 2000 in a field with low pressure and high pressure. This is yield of garlic in response to these different treatments they put out, either in furrow or seed treatments. And you can see untreated how low the yield was compared to some of these effective products. And just trying to find ways that they can manage this when fields become infected, and that's going to be the case for a long time to come. Now, when it comes to something that might work if you've got a piece of infected ground, you don't have too many options for moving your onion or garlic around, is garlic juice. And this is fascinating because garlic juice is produced, well, there's a company called the Garlic Company in California that sells garlic juice as a way to treat soil, to trick the sclerotia into thinking you've planted an allium crop. They germinate, there's no crop to infect, they die off. And so this is similar to a product that was made in New Zealand called Alliup, which is also a germination stimulant for onion white rot. It's basically these sulfide compounds, diallyl sulfide compounds, that are added to the soil to trick the fungus into thinking you've planted a crop. So this is results from a trial that was done in Bakersfield, California, a big onion production and garlic production region. This is % reduction in inoculum in the soil after treatment with either nothing or garlic powder, dehydrated garlic powder at 3 different concentrations, or what's called DADS, diallyl disulfide. It was a commercial formulation of the sulfide compounds, or methylbromide fumigation, which, you know, is sort of extreme end of synthetic fumigation. And it is really interesting to see the degree to which the inoculum density could be reduced by things like garlic powder. And garlic juice does the same likewise. So the DADS, you can see, was as effective as the methylbromide. There's some key things you need to know if you're going to use something like garlic juice to try and trick these sclerotia to germinate. One is that you shouldn't apply it too soon after you have an outbreak of white rot. And the reason is these sclerotia have an inbuilt dormancy period. That's for several months, that when the sclerotia are newly formed, they will not germinate even if you do have the garlic juice applied. You have to wait for several months or preferably the next season to use it because they won't germinate immediately, kind of like some seed have dormancy. Also, if you have a lot of volunteer onion or garlic present, those sclerotia are just going to keep growing. So you have to get rid of all the volunteers. And then once you've applied that garlic juice or garlic powder, you have to wait several months to make sure those sclerotia have all germinated and tried to do their thing before you plant an allium species. So you can't just put it on and wait a few weeks and then plant your crop. Also, that these stimulants, if it's too cold, they don't work as well. So just recognize that your soil temperature can't be too cool. So you want to apply it when your soil temperature is below 68, but above 50. So yes, this is very promising, but just recognize the biological constraints that both for when the sclerotia will be active as well as the activity of the sulfide compounds. So it's encouraging. It can be very effective. It just has to be done correctly, recognizing how it's a biological organism you're working with and trying to control. All right. I don't know, Laurel, if we have any questions on white rot before I move to the next one.
I do not see any questions at this time.
Okay. If anyone wants to raise their hand, I'd be happy to answer, but otherwise we can keep going. All right. So downy mildew. This was a disease Laurel asked me to speak about because we've had some issues with downy mildew show up on a number of farms. And I put in parentheses after downy mildew, Stymphalium leaf blight, because very often when you get downy mildew show up in an onion crop, you very quickly see Stymphalium leaf blight come in. And sometimes people don't realize downy mildew was even there in the first place because Stymphalium leaf blight comes in very opportunistically on the lesions and the dying tissue that downy mildew killed. So this is a photo I took of an onion crop where I don't know if you can see in the middle of this picture where this gentleman is leaning over. The onions are a little shorter. You can see some leaves dying back. This was a hot spot of onion downy mildew. And you can see how those leaves are dying back. So when you look at it, so that photo was taken in central Washington. This photo was taken in Western Washington. This is a field in Skagit County that I went to look at. And it looks like someone took a blowtorch to the onion crop and those leaves died back. So this onion crop first got downy mildew and very quickly after that got Stymphalium leaf blight, which gives it that black color because the fungus Stymphalium produces these black spores that just make the tissue look like it's been fried. So with onion downy mildew, the first thing you might see is some sort of yellow, or what we call chlorotic or yellow lesions. These are actually photos in a seed crop, so I apologize. But similarly, you'll see these yellow or chlorotic lesions, and then they'll start to look like they're dirty. It just looks like this, like soil adhering to them. But all of that dirt is actually the spores of the downy mildew pathogen sporulating on that tissue. And this is more extreme where it's producing lots and lots of spores. So this looks like dirt, but it's actually the pathogen. And this is where it rained, and then you can see it look like the spores are being washed off. And here you can see in an onion seed crop all these very bright yellow lesions that show up. So it's caused by not a true fungus, but what we call a water mold, or we used to call them fungi, but now called water molds or oomycetes. So the pathogen name is Peronospora destructor, the name destructor because it's so destructive. But it's not a true fungus, and that's really important because these are more closely related to algae than they are to fungi, and that's why they're not called fungi anymore. And you can see again that dirty looking appearance. All allium species are susceptible. So this pathogen can only infect living host tissue. It doesn't feed on dead tissue, it can only feed on live tissue. And it produces two types of spores. The spores that it forms on the leaf tissue that look like dirt adhering to the leaves or the seed stalks are what we call the sporangia. And these are wind and splash dispersed, and they produced in abundant numbers. They are produced when it's cool and damp, or cool and wet. And then it produces another spore type, excuse me, called an oospore, that can survive in the soil and is much more persistent. These sporangia don't survive very long under hot, dry conditions. They're aerial, they're not in the soil. Oospores can be in the soil, in crop residues, and they can be wind and splash dispersed. And although there's evidence that potentially the pathogen can be seed-borne, it's not a lot of evidence that seed is a primary source of inoculum. Instead, it's really the volunteers, bulbs, or infested crop residues that appear to be a major source of inoculum. And so things that spread the soil, spread wind and water, transplants, infected transplants, or infected bulbs, if you're moving bulbs around, can be a source of inoculum. So these are close-up photos I took of the oospores. And you can see they're very round, but they have a very thick wall around them, which allows them to persist in the soil. And these are the aerial spores, the sporangia, that are produced attached to these little structures. They look to me like deer antlers. These sporangiophores, so spore-bearing sporangiophores, basically come out through the stomata on the leaves, and then they produce these spores that are wind dispersed, look like lemons. And so what you're seeing when you look at these leaves that look dirty, close-up photo here, you can see the sporangiophores, the sporangia are attached, the spores that get blown around, and that's really what this dirt-like material is that's attached to the leaves or the seed stalks. And one way to look at these, if you're not sure, is I like to hold the leaf up like this and bend it over and hold it up to the light, and you can see the sporangiophores and the sporangia like little hairs along the leaf that can help you distinguish this from just soil adhering. So what favors downy mildew? It tends to do best when it's cooler and wetter. So temperatures, the low 70s, 60s, 50s, periods of high humidity, lots of extended periods when the foliage stays wet. The fungus sporulates anywhere from 43 to 80, so it'll actually sporulate at warmer temperatures, but still needs a lot of moisture. So the optimum temperature is in the 50s for this pathogen. This means we seem to see more problems with downy mildew in crops where you have a dense canopy. So either if you're growing onions close to a lot of other thick vegetation, or you're seeding your onions very densely, or you're near a row of trees, or in some seed crops where you have dense vegetation, dense canopy, there's less air movement in a dense canopy, which tends to mean a higher period of high humidity, a longer period that the canopy stays wet after rains or after irrigation. And that's one of the big factors that drives downy mildew in our area. If it's above about 75 and dry, it tends to become a lot less favorable. So dry, sunny weather is much less favorable. And that's why downy mildew is not normally a big issue in central Washington, but it is a much more problematic issue for onion growers in western Washington. Once the pathogen infects onion leaf tissue or seed stalks, you don't see any symptoms initially for a period of 1 to 2 weeks. And then you'll start to see that yellow tissue forming, and then you'll start to see sporulation. These spores are produced at night, and then they're dispersed by day. Night tends to have high humidity, and these spores, the airborne spores, can survive for a couple of days on the foliage, a shorter time if it's dry and warm. Just to show you how rapidly downy mildew can develop, this is a picture taken in New York by Christy Hopeting, an extension specialist at Cornell Extension. She took this photo in August 13th of 2014, same field 2 weeks later. just to show you how under favorable conditions, this disease can be really devastating. And so, unfortunately, we do have more favorable weather in Western Washington. Downy mildew lesions very, very often are followed by a secondary infection by this Stymphalium leaf blight pathogen that I mentioned before. So this will take on that dark appearance. You can see these much more darker sporulation that's developing in these lesions. And this is Stymphalium leaf blight coming in secondarily. Stymphalium leaf blight is caused by a true fungus, Stymphalium vesicarium. So here you can see a downy mildew lesion on the scape on the right and one on the left. And here's where Stymphalium vesicarium has come in secondarily and colonized. You see this black and purple type of lesion. And this is, again, Stymphalium coming in from damage caused by thrips, not caused by downy mildew, but Stymphalium is very opportunistic. And just to show you the extent to which these downy mildews can be colonized secondarily by Stymphalium, there's some very charismatic symptoms that you can see in these combined infections. There's also a disease called purple blotch, which is caused by Alternaria pori. It's closely related, cousin to the Stymphalium leaf blight pathogen, also causes these dark lesions with a purplish tinge to them. Both diseases caused by different pathogens can look very, very similar. The spores are a little different. Won't get into detail, but just to tell you that this Alternaria pori I very, very seldom see in Washington. Stymphalium is the one I usually see coming in secondarily on downy mildew lesions. So how do these two pathogens spread? They can come in secondarily, usually on an inoculum that's surviving on volunteers or infested residues, moved by the wind, splashing water, people, tissues. These pathogens also need high humidity. They also need extended periods of leaf wetness. They tend to do better at warmer temperatures than the downy mildew pathogen, and will often come in, as I said, after the downy mildew pathogen has established. So crop stress tends to favor them. Overhead irrigation or rains. Older leaves tend to be favored. There's quite a bit of difference in susceptibility of various onion cultivars. And there are some strains of the fungus that seem to be much more aggressive than others, particularly in East Coast, Midwest states have been seeing this disease become more problematic. So how do you manage downy mildew? Start clean, particularly if you're buying transplants. Inspect those transplants, make sure that you're not bringing in material that's already infected. Usually the recommendation is once you've grown onions or alliums in a field is to stay out of that area that you've planted for 2 to 3 years, ideally longer. And try to find some isolation space-wise and time-wise where you've had an allium crop before you go back to that allium crop. How do you keep your field aerated well? So think about the direction you're planting your rows. Is there prevailing wind direction where you're growing your onions? Can you take advantage of that prevailing wind direction to get more air movement through those rows, which will help speed up the canopy after you've had rains or irrigation? Avoiding too dense a planting, avoiding planting your onions right next to tall vegetation that'll minimize air movement can all make a difference in how quickly that canopy will dry down after any rains or after irrigations. If you do irrigate, obviously surface or drip irrigation is going to be more favorable for managing the disease because you're not wetting the canopy every time you irrigate. But many growers just use sprinklers or overhead irrigation, which is favorable for downy mildew. Once you've harvested your crop, getting rid of your infested crop residues by burying the residues, incorporating them into the ground so that they break down, because the downy mildew pathogen has more limited survival in soil. Also avoid excessive nitrogen fertilization because lush, dense canopy, excessive nitrogen fertilizer favors that and tends to create more favorable conditions for the disease. Unfortunately, there's not a lot of good resistance to downy mildew in commercial cultivars, and certainly for seed growers, that's even less of an option. I'm not going to go through the list of fungicides because for commercial growers, there's a wide range of different modes of action that they can utilize. This has become a problem because in areas like New York, the downy mildew pathogen populations there have developed resistance to many of the fungicides that growers use. And so there's always concern among in commercial production areas to make sure growers are rotating these different modes of action of fungicides they use. In areas like New York, they also have forecasting systems to tell a grower when conditions are particularly favorable. So I won't go into the details of this, but if anyone is using fungicides and wants to know more detail, I can certainly provide that information. The Stymphalium leaf blight, which comes in secondarily on downy mildew, again, rotation. Once you've grown onions, stay away from that field for a couple of years. Start with good quality seed. See if you can manage your irrigation to get the canopy to dry out adequately between irrigations if possible. Utilizing things like you're planting your rows in a direction that the wind will move between the rows more effectively, destroying onion culls, onion residues, minimizing damage, and also for Stymphalium leaf blight, there's not really good resistance, but some cultivars have better resistance than others. There are some fungicides that can be used, but again, in the case of Stymphalium leaf blight, it's typically coming in opportunistically on top of something else like downy mildew. So your primary goal is to manage downy mildew. So I see a comment in the chat. Okay, so Heidi asked, for going back to the white rot question, if you use garlic powder to control white rot, can you plant a different crop while you're treating? Yes, you certainly can. You want to maximize the benefit of that garlic to stimulate the germination. It's not going to, sclerotia are not going to germinate in response to exudates from any other genus, just allium. So yeah, you could utilize that as well. Okay. Any other questions on downy mildew? Okay. So one of the things Laurel talked with me about presenting on today is how do you manage your onion towards the end of the season to maximize what we call field curing in order to minimize your risk of bulb rots developing at harvest or after harvest and storage. And this comes down to problems that we often refer to as neck rot. And sometimes a grower will call me and say, I've got neck rot, what is it? And a lot of plant pathologists think that neck rot is a botrytis, which is a fungal infection, and that's what we usually reserve that name for. But growers just see the neck as starting to rot or fall over, as you can see in some of these pictures in the middle and the right, and we'll call it neck rot without necessarily knowing what the cause might be. And so there are a lot of things that can cause this. So one of those is a group of fungi belong to the genus Botrytis. So Botrytis neck rot is the classic name that we use, caused by things like Botrytis aclata, Botrytis alii, and a number of other species that can be problematic. These are true fungi that infect through the neck and can move down into the bulb, start to cause a rot, and then later on form these sclerotia, the sort of grayish to black sclerotia. And you can see this is clearly not marketable and not edible at all. There's also another fungus called Aspergillus, which causes black mold. And it likes much warmer temperatures than Botrytis, but the same thing where you can get infection moving down the neck into the bulb, causing a rot, or you can have this external discoloration. And Aspergillus is a problem in particular because it produces abundant dry spores that can be blown around. Aspergillus species also produce carcinogenic compounds, so you don't want to be eating onions that are infected with Aspergillus. There are also bacteria that can cause bulb rot. So these are symptoms caused by bacterial infection moving down the neck into the bulb, and that you can see how which leaf got affected based on which fleshy scale is showing the symptoms. The infection moves down the scales, tends not to move between the scales, but it's a much more slimy, wet rot compared to Aspergillus and Botrytis. So all of these can cause what someone might call neck rot. And this is just, again, showing a close-up of symptoms caused by the bacteria where the leaf attaches to the neck. It starts to move down that leaf into the neck, and then that makes its way down into the bulb. And you can see where this infection had progressed all the way down into that fleshy scale. So onion plants are exposed to these bacteria, to the botrytis and aspergillus all the time. These organisms are everywhere. They're in our soils, they're present. So as an onion grower, you're never going to escape the presence of these organisms. And I think that's an important first thing to recognize. So the key thing is, how do you prevent these organisms from getting into that neck and making their way down that neck into the bulb? All of these organisms, the bacteria, botrytis, and aspergillus, they're favored by moisture. So in the absence of moisture, when you have dry tops, dry necks, dry foliage, there's not much they can do. But moisture allows the spores of botrytis and aspergillus to start germinating, or the bacteria to multiply and be able to build up a population to start causing damage. All of them tend to get splashed up from soil onto the leaves or into the neck. That's one of the primary ways that they can get into the neck. And there are two things that have to happen in order for that inoculum that lands on the foliage or in that neck to start to cause a problem. You have to have moisture, it's one of the things I mentioned, and you have to have dead or damaged tissue. If you have perfectly healthy tissue and moisture, you tend to not see an issue. But it's when you've got dead or damaged tissue, either from injury, windblown damage, or like a hailstorm, or people or machinery moving through the crop, or when those tops start to fall over at the end of the season, because the necks are finishing up and the tops naturally fall over. We call that tops down. That tissue is now starting to die in that neck, and it needs to die so that that onion can get into a nice, hardy, dormant stage for storage. That dying down period, or tops down period, you've got tissue that is dying, and you've still got some moisture present when it hasn't fully dried yet, is one of your most high-risk periods for these bulb rots to occur. So the other thing that distinguishes which of these might be a problem is, besides having dead or injured tissue and moisture, is the temperature. Botrytis is favored by cooler temperatures. Aspergillus and most of these bacteria that cause bulb rots are favored by warm temperatures. So these are heat-loving organisms, whereas botrytis is cool organism. So basically, you're in a race. You're in a race with these pathogens that can cause rot. You want, when your onions tops start to fall over, you've got dying tissue, you can't avoid it. The necks are still green, so there's still some moisture present. So you're in a race to get those necks dried down as quickly as possible before any spores or bacteria that are present in that neck can start multiplying and becoming active and start moving their way down that neck. So it's a race to dry those necks, cure them as quickly as possible before those pathogens get into the bulb. The key things you want to look at is, how do you avoid excessive fertilizer applications, avoid irrigating too much or irrigating too late when those necks are starting to fall over. That can be a really key driver of risk. If you fertilize too much, you can get what we call bull necks. A bull neck is a very thick, large neck, which means it's going to take much, much longer for that neck to finish curing and dry down properly. So really key practice here is what you do late in the season. That's going to help speed up that field curing. And to illustrate just how important that combination of moisture and dying tissue is, I want to give you an example of that I've seen multiple times. It's a seed crop example, not a bulb crop example, but it illustrates the key combination of those two factors. So this picture on the left was a field for an onion seed crop that I was visiting when I was on sabbatical and overseas. And I was told by the field rep that I was with that this grower tended not to use enough nitrogen. When I asked him, why are these seed stalks of scapes so yellow? They should be green. And he said, well, that grower just tends not to use enough nitrogen. And I knew, based on my experience working with onion seed growers in the Pacific Northwest, that that probably was not the case. And I asked if we could go in and look at the crop. And so we went in and looked up close. If you went down to the base of these seed stalks, when that seed stalk is developing, the leaves that were there in that first season start to die back. And those leaves form a dead sheath around the base of the seed stalk. I don't know if you can see that in the background here. So this particular seed stalk in the front, I had pulled the outer dead leaves down, and you can see that grayish, those grayish concentric rings. That's all botrytis sporulating between the layers of the dead leaves that had formed a sheath around the base of the stem. So the overhead irrigation, the spores get washed down there. Those leaves are dying because the seed stalk is forming. So you've got dead tissue and overhead irrigation. It allowed botrytis to start producing spores inside that tissue and completely girdled the scapes, the seed stalks, So now there was no way for the plant to continue to take up water and nutrients from the soil. And so the plant was taking any nitrogen that was present in that scape to try and finish making that seed, making it look like it was nitrogen deficient. When it had nothing to do with nitrogen deficiency, it had to do with botrytis infection around that base of the stalk where you had that combination of dead tissue and moisture being trapped. So just a really good lesson. And the other place we see this happening in seed crops is you often see is a botrytis lesion forming right where the umbel attaches to the top of the seed stalk. And the reason is when that umbel is forming, it has this membranous tissue surrounding it. It opens up, as you can see here on that top right-hand picture, opening up, and then that dead tissue stays attached at the base of the umbel. And it can sometimes be out wide and catches rain or overhead irrigation, and now you've got dead tissue and you've got moisture. So again, that infection tends to happen as those spores land on that dead tissue. There's moisture there and they grow in, and you end up with that blighted area forming underneath the umbel. And so this is the same principle when it comes to a bulb crop. When those tops fall down, you've got tissue dying, and there's a period when it's still moist. And so you're, again, trying to raise that. And this is one of the reasons why growers in commercial production will use what we call these so-called systemic fungicides to try and protect that tissue before those spores can germinate and grow. But I want to mention something that I think is not very well understood in disease management, and that is when if you choose to use a fungicide and you think it's systemic or not, what are you actually getting out of that? So most people think the word systemic means that the product will move throughout the plant. But there's 3 types of systemic movement of fungicides. And I think this is really important to remember for those of you who might choose to use fungicides. When a fungicide says systemic on the label, it doesn't always explain, unless you read the detail on the label, whether it's translaminar, which means it just moves across the leaf, it's not moving very far, or locally systemic, it can move a little bit of a direction, or whether it's truly systemic, can move throughout the plant. So if you apply it to the soil, can it be taken up through the roots into the foliage? Or if you apply it to the foliage, can it move down as indicated by this red arrow? And this is based on whether or not the product moves in the xylem or whether it moves in the phloem. So most fungicides are xylem translocated. Xylem moves water and nutrients from the soil up through, basically taken up by the roots, goes into the xylem, and it moves up the plant. Xylem only translocates in one direction. It's up and out. And so 90+% of fungicides, if they say systemic on the label, they're actually xylem translocated. They can only move in one direction, that's up. So if you apply a xylem translocated product to the leaves, it'll never be translocated down to the roots unless it's translocated in the phloem. And there are very, very few fungicides that are phloem translocated. Phloem will move photosynthates from the foliage around the plant, up or down. So phloem translocated pesticides can be moved either direction. Most insecticides, most herbicides, when they say systemic, are phloem translocated, but it's completely opposite for most fungicides. And this is one of the reasons we sometimes see failure of fungicides to work, because people assume systemic means it'll move throughout the plant, when in fact the only fungicides that are phloem translocated are the phosphorus acid types like Alliet. Phosphorus acids are moved in the phloem. And this is an important point. It across all disease management principles, if you are using fungicides, to keep this in mind, because we see a lot of incorrect use of products because of this lack of understanding of what systemic means. And there's a really nice description of some of this in the Pacific Northwest Disease Management Handbooks in their pesticide articles section for those of you who would like to read up more about this. When it comes to bacteria, we do not have any systemic bactericides, unfortunately. The most effective products out there appear to be the coppers, but they're contacts, protectants, they're not systemic, they're not curative. And so oops, my slides are just going forward without me. So there's very limited ability to try and control bacterial diseases with pesticide applications. And I'll show you an example. We have been looking at bacterial efficacy to try and control bacterial diseases in Washington and other states around the US. In Georgia, they've seen some excellent efficacy. They had a trial, for example, where their checks had 74% bacterial rot, and some of their coppers were giving them less than 10%. In Washington State, we did a whole series of trials for 6 years trying to see if we could get good efficacy with copper applications. And what we discovered is that a large percentage of the onion bacterial pathogens that occur in central Washington are tolerant to copper. They've basically become resistant to the coppers. So we don't see very good control at all in onions using copper bactericides. And I caution this because what we've been doing for about 5 years now is research showing how growers can manage onion bacterial diseases using late season cultural practices like how to control your irrigation. So for example, there were trials done in California and Georgia showing that if you used overhead irrigation, solid set versus drip, you get a huge difference in the amount of disease in your total yield. So here you can see the yield. This was a trial in California under sprinkler irrigation was 116 tons per hectare. Drip irrigation was 131. So very significant difference. And the only difference here was whether or not you drip irrigated or overhead irrigated. Now, not everyone's going to use drip because of the resources it takes, the expertise it takes, but there's the fact demonstrating that getting moisture in those necks is a big driver of bacterial rot. So you can see there was 15% incidence of bacterial rot under sprinkler irrigation. Sorry, my slides are just jumping around without my knowing why. Let me go back and find the correct. I don't know how that happened. I'm going to stop and go back to, for some reason my slides are jumping without me moving them. Let me go back to where was I? Oh, all right. Apologies for that. Don't know why it's showing the wrong slide here. Apologize, folks. I'm not sure what's going on here. Sorry, Laurel. My computer seems to be freezing up on me.
Okay. Let's see if I may have the PDF of your presentation that I could share for you.
I will. Let me escape. Okay, I'll try it again. This does not normally happen, so my apologies to everyone. We'll see if I can get it to work now. All right. Share screen. And back to that slide. Can you all see now? Laura, can you see the correct slide?
Yep.
Okay, great.
Hold on. Yes, I can see the one with the table. Yeah.
Okay, fantastic. Excellent. Thank you. So this was, as I said, a trial that we've done over multiple years, part of a larger team working on rots of onions and storage, showing that when you switch from sprinkler irrigation, where you get regular water in those necks, to drip irrigation, we could reduce the amount of bulb rot from 15% to less than 1%. And this was over multiple years. So just a really, really effective form of control is how you irrigate your crop. We also had a master student look at how you do overhead irrigation. So if you don't have a choice of doing drip, you're going to have to use sprinklers. When do you stop irrigating your crop? Because remember, your high risk period is when you have a big neck at the end of the season. Water can get in very easily if you're overhead irrigating, and then those tops fall over and there's a drying period when you're at high risk. So over 2 different years in Central Washington, Tessa Bello did these trials where she terminated irrigation, what we call early or standard or late. And there was just a week between the early and the standard, a week between the standard and the late. And the standard was at about 50% tops down. And you can see that in plots that she had inoculated with these bacterial pathogens or non-inoculated plots, this is in Central Washington, which is very dry. Look at the difference in the amount of bacterial bulb rot. Oh my goodness, keeps jumping ahead in 1 year versus the next year. So we had different disease pressure in 2020 versus 2021. But under high disease pressure, you can see by keeping your irrigation going 1 week longer or 2 weeks longer, you can increase the amount of risk of bacterial bulb rot. We've also done some trials looking at how do you harvest. So in Georgia, some of the growers dig up their bulbs using what's called a chain digger versus straight blade undercutter. And the latter one causes a lot more damage to the bulbs and a lot more disturbance of the soil. And you can see the amount of infection, how much that differed between the chain digger versus the straight blade undercutter. Now, most of you are not going to be using these big machines to harvest, but it demonstrates the importance of damage to the onions or disturbance of the soil when you're harvesting. It releases that inoculum into the air and increases that risk that you could be causing colonization of those topped onions and infection. And when they looked at the difference between mechanical harvest versus manual harvest, the results were also very surprising. Over 3 years, you'd think you'd get less damage to the bulbs and less disturbance of the soil with manual harvest versus mechanical harvest, but they were seeing a much higher level of infection in the bulbs that were harvested manually than the bulbs harvested mechanically. When they took a closer look at these bulbs that were harvested by hand versus machinery, the one big difference they noticed is that the machine was leaving the necks very long when it was topping. When they were manually cut, people were topping the tops very short, close to the bulb. So they did a series of trials looking at how long the neck is when you top. So this is 1 inch, 2 inches, 1 inch, 3 inches, or 5 inches length of, it's metric, but that's 1, 3, and 5 inches. And if you look at the amount of bacterial rot in the bulbs after when they topped at these different lengths, the shorter the top you cut, the higher the rot. And so you can see, and oops, jumping again, these are the different lengths that they did the second year. Again, the shorter the neck, the higher the risk of bulb rot. And the reason is in Georgia, when they top when the tops are still green. So what happens when they're green? They haven't dried yet. So you're wounding when you cut, and there's still moisture, and you're probably introducing spores or bacteria because of topping from one onion to the next, out in the field. So this has been a really important lesson for us. If you have to harvest your onions when they're still green and you have to cut those tops, you want to cut the tops long so that there's time for them to dry out before that infection moves all the way down from that wound to the bulb. And so we also did a series of trials in Central Washington looking at when do you top. So in Georgia, they top green. They're fresh market onions. They don't store them. In Washington, some onions are sold straight away and not stored, like the Walla Walla fresh market sweet onions versus the storage types. So we did trials in Central Washington over multiple years where we topped early, topped standard 2 weeks later, or topped late. I won't get into too much detail, but I'm going to show you the pictures. So this is our 2023 trial. We topped early, mid-August, and you can see how green those necks are. Or we topped 2 weeks later, and you can see they're partially dried down, or 2 weeks after that. And when we measured the percent moisture in those necks at the time that we topped, we had on average over 50 bulbs, 90% moisture if we topped early, 59 or 60% moisture if we topped 2 weeks later, and less than 20% moisture if we topped 2 weeks after that. And you can see the photos of how much those necks had dried down when we topped. And when we looked at the percent rot in the bulbs, so this is inoculated plots versus non-inoculated plots. So the inoculum is increasing. This is marketable bulb yield, and this is the amount of bulb rot. You can see our inoculation was very successful at introducing disease. And when you look at timing of topping, early, standard, or late, marketable bulb yield, if we topped early, we had much lower yield, both inoculated and non-inoculated plots, than if we topped later, when the necks had dried fully. And this is because the amount of bulb rot was much, much higher. So allowing, when we wounded and it was still green, the bacteria that landed on those tops could move down into the bulb and cause bulb rot. And the nice way to look at this is this percent moisture in the tops at the time of topping, early, standard, or late topping, percent moisture ranging from 80% down to less than 20%. This is the amount of bulb rot that developed at harvest and after 5 months in storage. So a really important lesson is you want those necks to cure down. If you have to top green, top long. So reminder of the rot race. Once the tops start to fall over, the tissue's dying, it's no longer resistant to those pathogens. If there's moisture in those necks, you're at a high risk. The bacteria and the fungi become active and can move down the bulb. So you're racing to dry those necks before they get all the way down to the bulbs. When you top, you are wounding, which is allowing bacteria and fungi to get into that tissue. If the necks are dry when you're topped, that inoculum that lands on those wounds can't do anything, because so your neck length is not critical. You can cut short if your tops are dry, but if your tops are green, to make sure they're long when you cut. Anything else you can do that can speed up your field curing. In central Washington, they'll actually undercut the bulb, so it'll cut the roots to stop the plant from taking up moisture, so those necks dry more quickly. As I said before, terminate your irrigation early enough if you are irrigating. Avoid excessive nitrogen, avoid applying nitrogen late so that those tops will dry down quickly. And basically, you're thinking about what can you control to prevent disease. The amount of disease that you see in your crop is a combination of how much inoculum is present, how favorable environment is, and how susceptible your host tissue is or your variety. If you can reduce the length of any one of the three sides of the triangle, you can reduce the size of the triangle. The size of the triangle indicates how much disease. So let's take the example here where we've made the conditions less favorable. We've reduced the conditions of the environment. So for example, downy mildew, if you decide you're going to plant an onion crop and you know your wind is coming in a certain direction, you plant your rows into that primary wind direction, you're going to have a less favorable environment. So now your triangle is smaller. You still have as much inoculum present. You still have a susceptible host, but it's less favorable environment. Your triangle is smaller. You have less disease. If you can remove the amount of pathogen present, so let's say you use garlic juice and you trigger those sclerotia white rot to germinate and they can't infect, they die off. Now you have less inoculum, you still have a favorable environment, you're still growing onions, but your disease triangle is smaller, so you have less disease. Or you can perhaps control multiple factors. Or if you can eliminate any one factor, if you eliminate the pathogen, you still have a favorable environment, you still have a host, you have a flat line, you have no disease. And so I like to think about disease management from a grower's perspective. What can you control? Which sides of the triangle can you either eliminate or reduce the size of that size to get a smaller triangle, a smaller amount of disease pressure that you're likely to encounter? And I hope as we've worked through the white rot example, the downy mildew example, and now these bulb rot examples, you can think about them in relation to what do you have the ability to control on your farm, in your garden, wherever you're growing alliums, so that you might be able to reduce the amount of disease pressure you might face in production. If you do want more information on some of these bulb rot problems, I've been leading a project we call Stop the Rot. It's funded by the USDA, and there's a little QR code you can click on. It takes you to a web page with a lot of resources that we've been working on for years, for about 5 years now, with 12 different states involved. And with that, I'm going to stop presenting and see if we have any questions. Laurel?
Thanks. Yes, there's some questions in the chat box. The first one is, does downy mildew affect curing? And if your crop gets big enough by the time, let's see, if your crop gets big enough by the time it gets downy mildew, is there any concern?
So downy mildew usually does not impact curing. It's not a bulb rot pathogen. It's not a storage pathogen. What we do find if you get very severe downy mildew, I don't know if you remember that picture I showed you of the onion field in Skagit County that had all these dead, looked like someone had taken a torch blower and torched the top of the tops. The onion plants, when they're ready to, normally with the tops fall over there, if they die prematurely, they'll stay upright. And that can result in more risk of things getting into that neck and moving down than if the tops fell over. So that's the only time we see an impact of severe foliar disease on the bulb rot risk, is if those tops die standing upright and don't fall over properly. But usually downy mildew doesn't affect curing.
Okay. The only other question so far is, there's a question in the chat box and one that came directly to me, and they're both about rust.
That's right.
Do you want to say a little bit about that?
Sure. So rust can be a big problem. But I've seen it more problematic in garlic in Western Washington. I haven't seen a lot of rust on onions in Western Washington. I know there've been some years in California where rust has been an issue in garlic. We don't see a lot of rust on onions, but we do see it on garlic. And again, it's a foliar disease, not a soil-borne disease. It's going to be favored a lot like the conditions with downy mildew, where you've got periods of leaf moisture, poor airflow. So just being really careful about trying to control that environment as much as you can to minimize how long that canopy stays wet after rains or after irrigation. But it can be a problem. Yeah.
I'm really excited to hear about the garlic powder and garlic juice for the white rot, because I'd heard Jenny Glass told me about that a little while back, but I didn't know that it was kind of more mainstream. So that's pretty exciting, I think, for the folks. I would say the folks here that might have white rot at a smaller scale.
Yeah, because it's problematic once it comes in, and you might not have a lot of ground to rotate to. So yeah.
Yeah. Is there in any of the literature that you have on that, are there application rates if you're just using the garlic powder? Or
From what I recall, the concentrated garlic juice was like a gallon per acre, which doesn't seem like a lot, but it's very concentrated garlic juice that you can purchase from the garlic company. I don't know what it costs.
okay. And so that's actually um a
It's a
labeled product then.
Yeah. Now,
It's
I know
registered.
Jeremiah Dung is a professor at Oregon State University in the Madras area, and he's received funding from the California Garlic and Onion Research Advisory Board to look at sort of allium waste products, garlic and onion waste products. Can you use that as a, substitute for garlic juice because of the concentrated juice that it takes to make that and utilize it. And so he would be a good contact to find out what are the alternatives to having to buy that product, to be able to take advantage of your waste onion and waste garlic to produce crushed garlic juice or something like that. He would be a good contact to see what might work.
Okay. I'll email you afterwards. And if
Yeah.
I get some good information, I'll send it out to folks.
Yeah, and he's been working on that for a number of years, so he should have some information.
Great. Let's see. Does
Embolicia.
yep.
Yeah. So Embolicia skin blotch looks similar to Aspergillus. Embolicia skin blotch can look a little similar to Aspergillus. Aspergillus tends to be much, much drier, and Embolicia tends to be more problematic in garlic. Aspergillus I've seen most problematic in onion. Aspergillus can be an issue in Western Washington, but we tend to see more problematic in hot, dry climates like Central Washington. So I don't see a lot of Aspergillus black mold in Western Washington onion production. I have seen Embolicia more common in garlic. So I think we tend to be cooler and wetter and less favorable with our milder temperatures for Aspergillus than a hot, dry area like east of the mountains. I don't know if that helps answer Maya, your question.
And folks can go ahead and unmute yourself, Maya, if you'd like to just ask questions directly.
I have a couple questions.
Hi, Laura.
So to follow up from the downy mildew, so your onion crop, the onion tops get downy mildew, the neck isn't drying down. If you go through and manually knock over your onions, like what can you do in that situation to get your necks to dry down? I see that be very common. The neck is really fat and the top of my onion is totally fried.
Yeah, that's a good question. I know they've been looking at in New York trying to just taking rollers and we've actually done this in trials in Central Washington, is taken rollers and run them over the crop to force the tops over. There's always some kind of a risk that in that damaging process, do you potentially increase that because that injury? But if it's going to help your tops to go over and they're not falling over naturally, that in New York they've shown that has made a difference. So if you're seeing, Laura, that you've got a lot of foliar disease that's preventing the tops from falling over, that is something that in New York they've seen make a difference.
And so then insight there on like harvesting there's a wide range of when you can harvest your onion. When the top is like really green and fleshy, when it starts to fall over, when it's like completely dried down or partially dried down. You know, if you start seeing like the neck rots moving in, harvesting earlier and moving into like a dry environment, like any insight into like when you should harvest your onion if you see any amount of any disease really, but like the neck rot in particular.
Yeah, so it's a good question, Laura. And I think what we've learned from this is, you know, if you have ideal conditions, the best is to leave them to dry out in the field. But if you don't, like you've got early rains in September, which we can have, and you know, it can start raining a lot in September and your crop's not finished. I think the key thing is to not top too short, you know, keep that top long and get them into a place that where you can provide forced air to speed up that curing as best possible. In central Washington, they'll, you know, cut the roots if there's a way to sever the roots to stop the plant from taking up moisture. I don't know if that would be possible in your situation, but if you're still getting rains and periodic wetting of the tops, it's best to get them out of the field and into an area where you've got lots of forced air. I wouldn't try and use too much heat because heat will favor the aspergillus and the bacteria. But the key part is to get rid of the moisture. So air movement is really critical. Heating up that air a little bit can help because warmer air dries faster than cooler air. But you just don't want to get your air temperature above about 86 degrees or so because you start favoring some of those thermophilic type organisms. So
Okay.
big fans, get the air moving as best you can. Yeah.
Great. Thank you. This is also helpful. My final question to white rot. So it sounds like with your example of like the beetroot and planting it, like moving any amount of soil, whether it's on tools or shoes, to different locations can move the pathogen along, and any small amount of that pathogen, I assume, could like flourish and spread. Can you just like confirm that I'm hearing you say that?
Unfortunately, that is correct, Laura, because those sclerotia are quite small. And so, you know, they're just going to get moved around in this. If soil's adhering to your shoes, if soil's adhering to the tires on your equipment, that's how things can get moved around. So, you know, sometimes when I teach a field plant pathology class and I take students around to farms, some farms will have a foot bath before people can enter, you know, get your mud scraped off and then stand in the disinfectant foot bath so that if there is any inoculum on your shoes, it gets cleaned off. It is unfortunately with smaller scale farms that often are sharing equipment because you might not have the capital to buy your own equipment. That's one of the risks that comes with shared equipment is moving soil on tires and equipment. And so just trying to have a pressure washer that you clean off equipment before it goes from farm to farm is a really important way to diminish the risk of moving things like white rot or clubroot on brassicas.
So for white rot specifically, you know, just thinking more about like hand tools and boots, is just spraying off the soil sufficient? Like if there's no soil, is it fine, or do you have to also do a sanitizing step?
It's probably fine. The issue is the sclerotia are so small. They're like pinhead size, and so it may look like you got most of the soil off. I think that's your most critical thing is get as much soil off as possible. If you have a means to do a brief disinfectant application of oxidate or sanidate or something like that, it's not as corrosive. You know, bleach can be really corrosive on tools, but something like we use oxidate or sanidate in our greenhouses when we're cleaning. It's not the same organism, but you get the soil off, and then if you can do a brief like a hand spray bottle or a foot bath or something. Even just a little hand spray bottle that you spray down your tools before you move on can be really helpful. Just again, minimizing that risk a little bit further. But the more soil you can get rid of, the better.
Great. Thank you so much.
Pleasure.
Anybody else have questions? I don't see anything in the chat box, but folks are welcome to unmute yourselves and just go ahead and ask.
I see a thumbs up from James. Thank you. Yeah, and one of the things, we have beautiful weather in usually July, August, and it's half of September. The difficulty with onions and the late season is if we start getting early rains. Because the last thing you want to do to an onion top is get it wet when it should be curing. Looks like Megan has a hand raised.
Oh, go ahead, Megan. Don't see.
Oh, it's just, no, it wasn't Megan. Sorry. For some reason, my cursor showed up as a hand.
Oh, okay.
My Zoom seems to have taken on its own life today. Sorry.
I was gonna say, I don't see a hand.
My cursor suddenly turned into a hand.
Oh, mine did too. I see. Yeah. Okay. Yeah, when you put the cursor over the video feeds. Anyway,
Yeah.
okay. It looks like there's no more questions.
Okay.
Thank you so much, Lindsey, for joining us. I know this is really helpful, and I'll be in touch with a couple questions about contacts, and I really appreciate everybody showing up. I know that this is a really nice day that you might want to be outside in the fields at night. So thanks for coming. We'll send out a recording of this that you can share around if folks missed out. And also I'll share the slides from Lindsey's presentation.
Thanks, Laurel. Well, happy season, everyone.
Yep.